friends. So myself Deepshika Tiwari. Today we are going to cover the topic that is finite state automation. So first of all, what is finite state automation? A finite state automation can be represented by 5 tuples. That means we are going to have in this 5 quantities which are Q, sigma, delta, Q naught and F. What does these 5 quantities represent? So first is Q. It represents the finite non-empty set. Then the second is sigma, which represents finite not empty set of input. That means whatever input we will give. Next is sigma. It is a function group that represents Q into sigma into Q, where Q is a transition function. Now F, which represents Q, is the set of final state. So I hope that these 5 functions are clear to you. Now next, moving on to the transition diagram. Now what is transition diagram? It is a finite direct labeled graph in which each vertex represents a state and the edges are labeled as input and output. That means just like we are having 2 quantities Q0 and Q1. So this sign represents that the 0 is coming itself on it Q0, and this sign represents that the Q0 is giving as output 1. So these are the 2 states Q0 and Q1, and these are the inputs which we are giving, that is 0 and 1. So at Q0, what input we are giving? As we can see over here, that 0 is coming itself on it. So on Q0 the input is 0 Q0, and in case of 1 we can see that we are giving 1 as output from Q0 to Q1. Now second, moving on to Q1, so we are giving 0 as Q0 as the input and 1 as the output. So this is how we represent a transition diagram. Now in this finite state automation, we are having 2 types of automations. That is, the first one is DFA and the second one is NDFA. First one is DFA, that is deterministic finite automation. That is, the finite automation is called deterministic finite automation. If the machine is read an input string 1 symbol at a time, that means in DFA, that is deterministic finite automation, we will get 1 input at one time. Okay, just like we are having Q0, so we are getting 0 as first input and giving 1 as output. At Q1 we are getting Q1 as input and 0 as output, and Q2 as 0 as the input on self Q2. Next, moving on to NDFA, that is non-deterministic function finite automation. So in this, that at the same time we can get so many inputs, just like at Q0 we are giving both inputs, that 1 is and also 0. Then at Q1 we are getting input as 1 and giving output as 1. But while at Q2 we can see that we are getting as input 0 and 1 both. At Q4 also we are getting input both 0 and 1. But at Q3 we are getting input as only 0. So from this we can see that every DFA is NDFA, but its converse is not true. That is, every DFA can be NDFA, but every NDFA cannot be a DFA. So this is how we can differentiate between DFA and NDFA. Now moving on to its conversions, there's how we can convert NDFA to DFA. So as we can see that this is your transition diagram. So for moving for these transition states, that is Q1, Q0 and Q2, we are having 2 inputs at the same time, 0 and 1. So for Q0 we can see that we are getting input Q0 and giving as output as Q1. At Q1 we are getting both the inputs and Q1 as its output. So for converting it, we can see that for NDFA the states will be Q0 and Q1. So Q0 will at 0 we are getting Q0 and at 1 we are getting Q1. Again on coming on to Q1 and Q2 both. So we are getting 0 at Q1 and Q2 and Q1 as 1. So this is how we can convert that NDFA into a DFA. So I hope that this topic is clear to all of you. Thank you.